بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Stat 101, Major 1, Term 222. Let us have a look and solve it together. First part, multiple choices. What is it called when all items in a population have an equal chance of being selected in a sample? Well, if all items have an equal chance of being selected, this is called a random sampling. Suppose we select every fifth invoice in a file. What type of sampling is this? Well, every fifth invoice, this is a systematic sampling. When dividing a population into subgroups so that a random sample from each subgroup can be collected, what type of sampling is used? Well, this is a stratified random sampling. You select a random sample from each subgroup. Cluster would be selecting sum of subgroups, one subgroup or two subgroups, all subgroup. But here selecting a random sample from each subgroup, this is a stratified random sampling. A bank asks customers to evaluate the drive-through service as good, average, or poor. Which level of measurement is this classification? Good, average, or poor, you can say that good is better than average and average is better than poor, it is ordinal. Of course, it's not interval or ratio because there are no numbers. What type of variable is the number of gallons of gasoline pumped by a filling station during a day? Well, number of, immediately discrete. Number of means how many gallons, 2, 3, 4, 5, 60. But this is a discrete variable. Okay, your height and weight are examples of which level of measurement? Height, weight, this is ratio, level of measurement. Question 2, we have 20 students. This is marks of 20 students, sample. Develop a stem and leaf diagram for this data. Well, to develop a stem and leaf, I need to find the minimum and the maximum. If you look to the marks, 7 is the minimum and 45 is the maximum. So I immediately determine that I have data from 7 to 45. I'll take the stem to be the left number, which is 4. Here I can write it 0, 7. Okay. So the stems are from 0 to 4. So this is 0, 1, 2, 3, 4. These are the stems. And then I put the numbers. 15 means 1, 5. 18, 8 here. 21, 1. 9, 0, 9. 7, 0, 7. 27. 29, 23, and another 23, 38, 43, 45, 33, 39, 33, 37, 37, 35, 34, and 22. So this is the first step. Then I can write the stem and leaf in a better way. I can write here stem and write here leaf and write the stems again. And now I can write the leaves arranged. Okay, so 7, 9, 5, 8, And then here, the first smallest is 1, I have 2, I have 3, and then 7, 9, 2, 4, 6, okay. 2, 4, 6 items or data. Okay, here the smallest is 3, I have 3, 3, and then 4, and then 5, and then I have 2, 7, 1, 8, and 1, 9. Here I have 3, 5. So this would be my answer. To make sure you can check that the sum of these leaves is 20. So 2 plus 2, 4. And here 6, this is 10, 2, 4. This is 8, 2, 10. So 10 plus 10 is 20. So this would be the correct answer. The following frequency table represents the frequency distribution of the blood type of a sample of people. Okay. Develop a pie chart for this data. Well, to draw a pie chart, I can find the angles or the percentage. Any would be enough. But I need to find first, this is the frequency, I need to find the relative frequency. So to find the relative frequency, it is the frequency over the total. I need to add these numbers. So 30, 65, and so the total is 80. And now I start using the calculator and dividing 20 divided by 80. This is 0.25. Okay. 35 divided by 80. This is 0.4375. And then 0.125. 15 divided by 80 is 0.1875. So this is the relative frequency. I can write the percentages here, okay? So multiply each of these by 100. So I get 25%, 43.75%, at 12.5%, 18.75%. If you add all of these relative frequencies, you should get 1. And if you add all of these, you should get 100. I can sketch the graph using the percentages, or I can find the angles. Okay, it's up to you. To find the angle, I will multiply each percentage by 360. So 0.25, or each relative frequency, 0.25 times 360, this would be 90 angle. 0.4375 times 360, I'll have 157.5 angle, and this would be 45, and this would be 67.5. Okay. I can sketch, of course, a pie or a circle. If I say that this is the center, okay, and I can go 4 everywhere, to the right, to the left, okay. And I draw the circle. Just a sketch would be okay, because this is not as I wish, but good. And now, of course, if you go by percentages, you know that total percentage is 100. So for example, 50% would be half of the angle, 25% would be quarter of the angle, a quarter of the circle. So this quarter will represent 25%. Okay, I can write here single, or here single, and here 25%. No problem. Also, if you use degrees, you know that all the circle 360, 90 would be a quarter circle. So this is the single, 25%. Well, 43 or 44%, you know that this is 50 after 25. from here to here, this is 50%, okay, or 180 degrees. So I need 160 degrees only, or 44%. So still a few, if this is the middle, this is half, 45, 25 degrees. So it would be up to here, or up to here. Okay. Up to here, this would be the second portion, which is the 43.75%, and this is the merit. 12.5%. Now you can add 44 plus 12, okay, using the calculator. If you add 43.75 plus 12.5, it would be 56. Okay, so 56 is more than 50%. So this is 50%. So 56 would be somewhere here. Okay, and this would be, this is 12.5, and this would be 18.75. So almost, this is the graph. You can write here W and D divorced. This would be a pie chart. The following data represents the marks of a sample of 20 students in a certain exam. Okay, 20 students. Use the 2 to the power k greater than or equal to n guideline to determine the number of classes. So here I have n is 20 students. So I know that 2 to the power k should be greater than or equal to 20. Or if you take len both sides, you can here find 2 to the power 2 to the power 3 to the power 4 until you find the number greater than 20. Or I prefer taking the len of both sides, then k len 2 would be greater than 20, or k is actually greater than len 20 over len 2. And if you use the calculator, len 20 over len 2 will give you 4.32. This means k should be greater than or this number. A number of classes, it should be an integer. So k is 5. So the number of classes is 5. You can notice here that 1, 2, 3, 4, 5, the number of classes is 5. Based on the answer to part 1, determine the class width. Well, to determine the class width, we need to find the maximum minus the minimum and divide that by the number of classes, which is 5. So the maximum, what is the maximum here? 98. Yeah, 98 is the maximum. What is the minimum? 59. So 98 minus 59 over 5. Use the calculator. This would be 7.8. The data are integers, so we have to round this up. So I will round it to the closest integer, which is 8. So the class width would be 8. And also, if you notice here, if you subtract 75 minus 67, that's 8. Okay. If you subtract 67 minus 59, that's 8. So the class width is also given. Develop a frequency distribution by completing the following table. We need to find the frequency. To find the frequency, I'll make a tally. Okay. So here, for the first number, I look to the first number, 94. Where is it? It is in the last interval. So I'll put in the last interval 1. I write here 1. Okay. 88. Where is 88? It is here. 86 is also here. 63. Well, 63 is here. 92. 92 is in the last one. 79. 79 is here. 59. 59 is here. 68. 68 is in the second one. 85, well, 85 is here. 75 is here. 82 is also here. 72, this is the second line. 72 is here. 98 in the last one. 81 is here. 88 is here. 76 is, and now this is the fifth one. So I don't write it like this. I make it like this. Okay. This is 76. 89, well, 89 is also here. So this is the fifth one. 84 here. 73 is here. And finally, 82 and 82 is here. So I have 2, 3, 6, 6, and 3. Okay. This is the frequency. The relative frequency, I need to divide by the total number, which is 20. So 2 divided by 20 is just, use the calculator, it's 0.1. 3 divided by 20, 0.15. 6 divided by 20, 0.3. And this is 0.3 and 0.15. Again, if you add all the frequencies, you should get 20. If you add all the relative frequencies, you should get 1. Develop a histogram based on a frequency distribution you consider. Well, a histogram I need a y-axis and x-axis. Okay. Here I put the frequencies. Here I write frequencies, and here I write the classes. So the classes starts first class from 59 to 67. So let us say that this is 59. Then this is 67. Then 75. 83. 91. And 99. And the frequencies, I have numbers from 1 to 6. So let me say this is 1, 2, 3, 4, 5, 6. So the first class frequency is 2. He said frequency distribution. Okay. If he says relative frequency, then I have to put the relative frequencies here. So the first class is 2. So I take this up to 2. Then this one to 3. This is to 6. And this is also 6. This 2, 6. Then the last one is 3. And this is 2, 3, 6, 6, 3. You can write, if you like, you can write it here. 6, 6, 3. So this is the frequency distribution. A librarian from Prince Sultan University is checking the number of books borrowed by university students. He recorded the daily number of books borrowed by students during the past 10 days. The sample data, so this is again a sample, are shown as follows. Okay, so how many? 10. 10 days. Compute the following and show your calculation. Well, the mean, you just add xi, summation xi, and you divide by 10. So you divide by the number, the sample size. If you add all of these numbers, you will find that their total is 63. So the mean is 6.3. Of course, you can also use the calculator. The median, we have to arrange the data. So the smallest is 3. Then I have 5, 5, 5, 5, 4 5s. Then I have 1, 7. How many? 8, 8, 8, and then 9. Check 2, 4, 6, 8, 10. So really I have 10 numbers. Well, the median, the position of the median, you divide the sample size by 2, which is 5. That's the position. Then the median is, you go to the fifth position, 1, 2, 3, 4, 5. So the fifth position is 5. So this is an integer. So I need to find the median would be in the 5th 0.5 position. Okay. So it would be between 5 and 7. And you can see that this is really in the middle, 5 numbers to the right and 5 numbers to the left. So you add 5 plus 7 and you divide by 2. So the median is the most frequent data. You can see that 5 is 4 times. So we have the mode is 5. Standard deviation, well, the definition of standard deviation, square root of summation x minus x bar square over n minus 1. So you can subtract each number from the mean. You can 3 minus 6.3 squared plus 5 minus 6.3 squared. And since you have 4 5s, you can multiply this by 4. Then plus 7 minus 6.3 squared, then 8 minus 6.3 squared multiplied by 3 because I have 3 8s, then 9 minus 6.3 squared. If you add all of these numbers, this is the sum. It would be 34.1 over 9 because n is 10. So the answer would be square root of this number, which is 1.95. That's the standard deviation. Of course, you can use the calculator, go to mode stat and put the numbers and then find the standard deviation and then the 70th percentile. Well, the position of the 70th percentile is 0.7 or 70 over 100 times 10, the number of data. So it is the 7th position. So if you go to the data, of course, if you get an integer 7, you have to take 7.5 position. So this is 5, the fifth position, 6, 7. So 7.5 would be this position between 8 and 8. And the number between 8 and 8 is, this is the 70th percentile, is just 8. If you want, you can add 8 plus 8 over 2, find it 8. Or you understand that 8 is between 8 and 8. Well, this is what I wanted to say in this video. I wanted to solve this exam with you. Hopefully, you understand. So thank you very much and see you in another video.